Hi, everybody, and welcome back to HCD Mindset, the HCD Research vidcast. This is season 2, and we are doing a combination of things this season where we are sort of doing interviews as well as touching on some topics that are important in market research, consumer research, and consumer neuroscience. Today, we're going to be talking about sample size and all the things that you have to consider when you're doing research that are important when it comes to choosing the sample, the people that you are going to be measuring. Now, before we launch into that, first I'm going to welcome back everybody that's been joining us on this journey, and also give a big hearty welcome to those of you that are new. Welcome to our vidcast, a little bit about who we are. My name is Michelle Niedziela, PhD in Behavioral Neuroscience and VP of Research and Innovation at HCD, and as always, joined by Kathryn.
Hi, everyone. Yes, welcome back to HCD Mindset. I am Kathryn Ambroze, the Manager of Behavioral and Marketing Sciences. And before we get started, I'm going to let Michelle share a little bit about HCD.
So for those of you that don't know us that well, we are a research house, consumer and market research and consumer market science. We basically measure consumers to understand how they interact and perceive, evaluate, and respond to different types of stimuli. Could be consumer products, it could be communications, but we use a variety of tools. So anything from the more traditional tools like surveys, focus groups, things of that nature, but also using more cutting edge and technology-driven tools, maybe from neuroscience or psychology or AI or whatever it might be. We call that applied consumer neuroscience, and it helps us to better understand that interaction that consumers have with, the experiences that they have with products or brands or whatever it might be. And we do that kind of work from the early stages of exploration, maybe within product development or understanding concepts, all the way through validation, perhaps through marketing or final product. We do this around the world. Our tools can be done either online or in person. Basically, we go anywhere you need to measure things. Kathryn, for example, is not at our U.S. home base, which is in New Jersey. Kathryn, where are you?
I am currently in London. I'm in the UK, and I enjoyed a great morning tea, so I'm really acclimating well.
Good job. So you see, it's fun. We have a lot of good times doing research globally. But without further ado, let's talk about the topic at hand, which is a really good one because whenever we talk to clients about setting up research, you have to consider who you are studying. When you're doing consumer or market research, the people you're studying are typically the consumers, right?
Right. Yeah, exactly. And this is a really important topic because whether you choose to do behavioral work, whether you choose to do work a little bit more in the psychology space or just traditional research, sample size is really something you really should consider regardless of the type of research that you're going for. So really the question is, what is a sample? And it's really nothing more than just a subset of the population. That's the easiest way.
You're taking a sample of the people that are out there, right? You're going into the population of the world, right? Who are we going to measure of all the people in the entire universe? We're going to measure this group of people.
Yeah, exactly.
So when you do that sample and you take this little piece, right, of like the billions of people, right? What is important about those people?
Right. So in general, it's really useful for analyzing the sample data, and that's really how you get that descriptive statistics. So it's the samples that are for the population, and that data that's obtained really helps you get an overall idea of the entire underlying population. And that's what's really
sample should be representative of the population that you're interested in. So
yeah, absolutely.
If you're, for example, you've got wine here in the bottom right corner. If you are going to do a wine study, you might want to make sure that your sample is representative of people who drink wine, right? Or at least of age to drink wine. So you have to take into consideration age. There's other factors. Maybe you're particularly targeting a type of consumer, right?
Yeah, absolutely.
So maybe it's women, or maybe it's men, or maybe it's people that live in the Northeast, right?
Right. So that's really, you have to focus on what is your target demographic. That's a really big, important question that you have to ask yourself. And I think the wine can also just be used as a metaphor because it's just like you're sampling wine at a vineyard. You're just taking a small quantity and getting a taste of what that whole bottle is like. So what that whole item is like. And I think that's what that's a really great analogy that you could use when you're trying to understand a sample. It's, again, like you said, you want it to be representative. And if you are considering certain factors, like you're considering, like you mentioned, age, gender, those are things that if you want to make sure that you're getting a wholesome idea, you have to hit certain targets and hit those numbers that will give you that full representative example of that population.
And I think we're probably going to talk about this even more as we go through this topic, but when you're looking at a general sample, so a general sample means like the general population, like of all the people out there, billions, right? Or maybe you're talking about general US population. And if you're going to get a sample of that general population, in order to make sure that it's representative, sometimes we do things like use census data, right? So you can find out what the census data says that the United States looks like. And it should be a certain a certain percentage of your sample needs to be this age. A certain percentage of your sample needs to be female. A certain percentage of your sample needs to be African American. You have to make sure that if you're going to say that this is Gen Pop, as they say, that's the colloquial way of saying general population, you want to make sure it's actually representing that general population.
Absolutely. That's such a great point to bring up, because when you are really, when you are using these samples, you're using the samples to help you draw inferences about how the population really responds to whatever you're testing. So it's those population parameters that you're trying to get at. And in order for you to get at it, you have to have those, again, that representative sample.
Yeah, because I think that when sometimes people say Gen Pop, people might have the misconception that they just say, throw the survey out there to whoever can come in. But no, we still have to ask what are called demographic questions to find out kind of who these people are. How old are they? Where are they located? What race are they? What ethnicity are they? Sometimes how much money they make, how much education did they have, just to make sure that it is representing your sample. It's like a little gut check. Do I need to dip in again for additional sample, as they say, to sort of round out that original sample?
Exactly. And we've discussed this many times before, but if you aren't careful and you don't have those questions in place, then there is a possibility that you're skewing your sample population, and then you're not getting that real wholesome idea of who's out there. And the truth of the matter, if you're trying to do Gen Pop because all of your consumers use that product, you want to make sure that you are getting an understanding of all of those consumers. So,
and I like that you have on this slide, why is it so important? It is very important to consider who your sample is, because whatever product you're making, it shouldn't be skewed or biased towards only one population, right? And that's definitely a problem that we see in scientific research. I remember in graduate school, and I recommend this book to everybody, there's a book called Even the Rat Was White. And, it's really interesting look at how, throughout even academic scientific research, there is bias. A lot of the research that's done biologically focuses on like male animals. So it'll be male rats and male mice. And that data may not represent what's going on with females of those species.
Absolutely. And, it's you could go on a whole rant about this, but it's true with even medicine that
absolutely, medicine.
Yeah, that humans, obviously, if you're biologically different, you might respond to something differently. Your cycles may be different, and those are they make it a little bit more challenging maybe to do this research, but it's absolutely necessary.
Right.
So
I even saw some interesting pieces on like skin disorders. That all the medical books on skin disorders and rashes and cuts and bruises and everything, all the imagery is on Caucasians with light skin. And so new books are coming out now to show on different types of skin, darker skin, different ages of skin, because it will look different on different people. And so just making sure that things are representative so that, treatments are accurate.
More inclusive, yes.
Diagnoses,
absolutely.
Treatments. and even, creating a cake for wine, right?
Yeah.
Obviously not as, medically important, but also it's just in general, it's important to be representative and to take into
Oh, yeah,
consideration everybody, right?
absolutely.
So kind of moving on, getting to that bias, tell us a little bit about this.
Sure. So really, when you look at samples and you're trying to get an understanding of common samplings, there are biases that are trying to be considered, because just like we touched on slightly before, was the idea that our medicine books may be slightly, well, they are biased towards, maybe a white male, or because of the research, the foundational research that it was based on, or, the certain age of the population. Maybe it didn't focus on a geriatric population. And so there are these biases that we do have to consider while we are trying to get a sample to make sure that it is, again, representative. So the first one here is this undercoverage. And it's kind of the idea that if you don't have enough coverage, not everyone in the population is included in that sample. So it's the idea that if you are looking only at a certain population, we'll stick with the idea of age, and you are looking at a skin disorder, let's say, it may look different on somebody that is 65 years and older. So that is something that you have to consider while you're trying to get these samples. Another one that you can consider is also here, that sampling bias. It's important to keep in the idea that it's when you randomly approach somebody on the street. So it's not necessarily a good representation, because you're just, maybe if you're outside a mall, you're only getting certain people that are outside a mall at that certain time.
Timing of the day, right? So sometimes when people do like a mall intercept, who are you expecting to find at the mall at 10 a.m. on a Tuesday, right?
Yeah, exactly.
Definitely not someone who has a day job, right?
Right.
So you have to think, who are you measuring then? You're measuring people who have the ability to go to the mall at 10 a.m. on a Tuesday, and that's what you're limited to.
Yeah, and that could give an overrepresentation of a certain group, and ultimately that will cause a bias due to that systematic underrepresentation of maybe those people that are working, and an overrepresentation of maybe people that are part of a night shift or something like that.
Right. Absolutely.
So yeah, it's important to keep those things in mind. And the third one we have here is that the non-response bias. So it's that idea that, if an interviewer is leading questions that maybe somebody doesn't want to answer, they may choose to be a little bit more shy towards giving a response, because they think maybe their response is socially unacceptable.
Mm-hmm.
You could say that it's kind of seen in polling with politics that often people may not feel comfortable sharing their views completely to an interviewer, and that can cause some bias in your results.
I think about this all the time. The people who are willing to come in to participate in a study, versus those that aren't willing, who feel that either they don't have time, or that they don't want to be wired up, or they don't want to be asked questions. They don't want to be in a group of people for a focus group. I feel like sometimes there are a certain type of people that are more willing to give answers.
Oh yeah, if you have an introvert, like a true introvert, there's a high chance that they won't feel comfortable just going right out and then say it is an interview and speaking to a stranger. So it's,
and there are ways
it's
to deal
something
with
to consider.
Right? So
check out our implicit association tests.
But yeah, it's also, maybe you shouldn't rely entirely on in-person focus groups, or maybe incorporate some larger scale quantitative online studies that people can feel less intimidated by, or that you can get some of these implicit results where they can maybe reveal things that they don't have to overtly state, or maybe ask questions in a way, or given in some sort of setting where, if you're going to ask them something personal, like let's say using tampons or using condoms, or something that people do tend to get a little more uncomfortable about, is there a way that we can put them in a situation where it is more comfortable, like using smart speakers or mobile phone surveys, something that removes a judgmental person,
Yeah, it's true. It's like you said, those sensitive topics. Again, I just have now medicine on my mind, but a lot of times people don't feel comfortable discussing certain, certain ailments that they may have and things along those
Yeah.
lines. So having those other options.
Another thing I once saw was that interviews, like there was a survey that was given, and interviews were sort of given as well to ask, people what they thought about a certain type of face cream. And it was for older women, and the woman giving the interview was quite beautiful and young, and she's asking these women about their wrinkles, and it seemed to me that could definitely put someone on maybe the defensive or feel uncomfortable, because here's this beautiful woman that has no wrinkles asking them about their wrinkles, right?
Yeah, absolutely. It's a very ironic situation to experience.
Yeah, it's hard. And it's no fault of the interviewer, right? But it ends up being something that can affect the participant. So you really have to think about how you might bias your sample in that way. And we also see this even in these tech approaches that we were talking about, where you can measure people at home. So I think a good one to mention here for bias, and sampling bias in particular, would be facial coding, online facial coding, right? Yeah. There's a lot of bias in that affects the sample, because first of all, if you're going to do online facial coding, you have to use someone's webcam. So they have to say, okay, you can access my webcam. And interestingly, a very large percentage of people will, when that question comes up, they opt out because they don't want someone looking at them, right?
Oh, right. Of course. Everyone thinks that the FBI is, sneaking a look at your
or, when does the access stop, they start to wonder, right?
Yeah,
But then also the facial coding algorithms themselves are really biased. So, for example, they struggle with different types of skin, so different shades of skin, for example. So things, the algorithms were based once again on white males, Caucasian males. And so when it comes to different facial features that are not typical of a Caucasian male, then facial coding struggles.
That's a really great point. I'm glad you brought that up. 100%.
Yeah. So it's kind of interesting that it's not just in the typical sense of how you go out and find the people, but it's also how some of the measures don't handle it very well.
Yeah. So this idea of simple random sampling, and how do you know if something's truly random? That's really what the question is here. What is it? So it's this idea that you are really getting a random population. And this is a topic that has to be brought up, because what is random? Yeah. If something is, truly random, you have to be prepared for it to be any sampling. So
I think that's what people don't realize a lot, is that random sampling means that you could have if you're going to take an actual random sampling of a coin flip, you could get all heads.
Oh yeah, 100%.
That's perfectly random. Yeah. But if you're going to get an even distribution of heads and tails, that's no longer random.
Right. It's true. So you want to keep that concept in mind of what is random. And so I just want to talk about a little bit of an example. So if you have a population, I'm going to go with maybe students from London, because I'm in London, and you want to draw a sample of 200 students. You write all the students' names on a piece of paper, and then you throw all those pieces of paper in a huge bin, and then you just pick them out. That is an example of randomly selecting 200 pieces of paper from a bin, because it's just by chance that you pick those things out.
But it does women.
What? I'm sorry?
They could be all women, because that's true.
Right. It absolutely could be all women. It could be, you could just happen to pick all the people with the letter T in their name. There's, all of these possibilities, and it may or may not happen. And that's what allows something to truly be random. So you want to keep that in mind, because every person has a chance at getting chose at that sampling stage. And that is what keeps it random. And that is, when you have something like a random sample, that's how you try to keep that bias to a minimum. So you can try, it's a really fine balance that you're trying to make sure that you have the correct amount of people that you want represented in the sample, in terms of having it be truly representative, but also you want to make sure there's no bias in your choosing.
So sometimes it's a combination of trying to be random, but also putting parameters on that randomization. So sometimes random doesn't mean truly random, it means counterbalanced.
Yes.
So you take a random sampling and then you test that sample to make sure you have representation, for example, using census data. And then you have to go back and get more random people to see if they can fill out the spots that you're missing. So you get an actual representative sample.
Great point. Yes.
But even searching for those additional people to fill the spots, that should be random. You shouldn't go out and pick specific people.
Right. Exactly. Because then if you pick specific people, then you don't have it being random.
Yeah.
So it's
then it's biased.
Yes.
Very much like
it's a fine line we're walking.
It's not always as simple as it seems.
Yeah. So a lot of people think intuitively, is bigger better, right? So it's this idea that if you are getting a bigger sample, is it more representative? I think that's a question that a lot of people think, the idea that bigger is better.
Like, there's 1 million people in that study, right?
They must have done it. Yeah, exactly. It must be really representative. But the thing is, no matter how big that sample is, it never makes up for if you have a bad sampling procedure. So like we had just said, if you are going and picking out specific populations, then it's not random. And that doesn't mean, just because it's big doesn't mean it's a strong sample. It's a strong representative.
I think a good example of that is, let's just go back to facial coding again. So because there's so much dropout from people who don't want to be having access to let you have access to their webcam. And then there's dropout because there's a problem with the algorithm with different ethnicities, or because someone has bangs, or because they have glasses, or they move a lot in the screen. There's data dropout. And so because of that, to make up for that, they increase the sample size, right? So instead of doing 50 people, they do 500 people, let's say.
Right.
But you still lose, let's say, 70% of the data. So you're still getting 70% of 500, but let's say then you go up and you say 1,000. So then you get 70% of 1,000. So you have 700 people, but those people might be still biased, right?
Right.
It doesn't matter how high you go, you still might have underrepresentation of different ethnicities. You might still have underrepresentation of the type of people who don't want their webcam on.
Exactly. So, if your sample is not random, you can increase your sample size as much as you want, but that doesn't necessarily mean that sample is good. That's really the core to it. But let's say you have an example where your sample is truly random. Does that mean that, bigger is then better? And technically, maybe it is. Like maybe, it is better, but only to a certain point. You get to a point where if you continue to increase that sample, it only really changes the results maybe slightly in terms of precision if you're trying to get, let's say like your subgroups or something like that. But then overall, is it going to make much of a change? Not really. So there is a sweet spot where you hit a certain number and then
it's not going to get any better.
Yeah, exactly.
But there's also a limit of a bottom limit, right? So you definitely have too few. So there are ways to find out if you have too few. And the most academic and I guess validated way is to do a power analysis, right? To make sure, because the reason you want a representative sample and the reason you want to have an appropriate sample size is because you're doing statistical analyses on your data. And having you need a large enough sample so that you can account for variability in the sample. So if, some people give on a scale from 0 to 10 on liking a product, some people give an 8, some people give a 6, you get all that data together and you get variability. Now, the larger the sample, the less variability you have, right?
Right. Exactly.
So, but in order to decide what is the appropriate sample to have the least amount of variability for a valid analysis, I know this is getting in the weeds, but you can do what's called a power analysis. And the reason that a lot of people don't do a power analysis is because you can only do a power analysis on existing data. Right?
Oh, I see.
It's a little bit of a catch-22. So a true power analysis has to be done on some sort of representative data to be able to say that, this is an acceptable amount of variability. So to truly be able to do that, you have to know things beforehand. And so a lot of times people don't have time to do little bits of sampling here and there to find out what the data could look like to do an appropriate power analysis. But there are some cheats you can do, right? So there's sources online that you can do a sample converter or calculator, right? So you can Google, population sample size calculator. And there are things you could enter in some variables like, okay, if I have this size of a sample, is that good enough? And it can give you an estimation of perhaps what kind of sample size you really need.
Interesting. Yeah. So it's kind of helping you to giving you a gauge essentially. And I think it's a really important thing that you brought up is that a lot of times clients have to decide between how large can we go in our population before we're getting a little risky with our budget. It becomes
or how low can we go is a lot of times the question.
That is true. Yeah. I should have started there.
The sample costs money, right? So the more people you're asking, the more money you have to pay. And, your budget is only so much. And so we end up having a little bit of I don't want to say battle, but more of like, let's say a discussion. Yeah. Weighing those things exactly. So we don't want to be spending crazy amounts of money to get millions of people to participate. We want just enough people that we get a valid sample, meaning that, the variability is taken care of. The power is strong. We have faith in these statistical results based on this sample. And so sometimes there's pushback, right? Where clients might say, but can we get away with, I know you said you want 100, but can we get away with 75?
Yeah.
And in some cases we do say yes, because, they may not be able to do the research unless they can only do 75 because they only have so much money. But then we have to give that caveat and be very strong and say, we're going to have to mark every slide with saying low sample size.
Yeah, absolutely. So there is a give and take approach that can happen where you hit that, what is most appropriate for that particular research.
Right. Absolutely. Yeah. Yep. Okay. So moving on, because I think that's a great point. And like I think you said before, it's one of the things you could talk about forever. Right?
It is. It really is. So, another thing that comes up quite frequently, does it make a difference when you're doing qual versus quant? So what do we mean by that? When you're, doing a survey, how many people, Michelle, would you believe is your bottom that you need to have if you're doing Gen Pop, let's say?
It depends on the type of questions you're asking or how involved the research is. But a lot of times the minimum is like 100. So if you're doing things like a max diff or an implicit or looking at liking, typically it's 100 or 200 to get a valid sample. The difference between qual and quant, that's a whole another episode itself. Like what's qual, what's quant? Quant literally means quantitative.
Yes.
And quantitative means numbers. And so you really want to have what's more like that, what we've been talking about this whole time. The sample needs to be representative, and you have to make sure that it works for statistics and analyses, because that's what quant does. It deals with numbers.
Yes, exactly.
And qualitative means it's really more descriptive, right? So it's kind of getting a little more of a descriptive taste, example, observation of what's going on, but it involves a much smaller group because you're going to be interviewing people, you're going to be doing focus groups, you're going to be
very in-depth with those particular people.
It's not numbers, it's a lot of words. And, sometimes they look at those words and do counts on the words, but there's some analyses you can do on qual, but those numbers are very small. So, your typical focus group might be like 10 people. And so it may not be exactly representative of, and it's hard to have 10 people represent billions, right? So sometimes they'll have to do multiple types of focus groups, but you do still try to have representation even in those small sample size or focus groups.
Of course. And honestly, with all of these examples that we give, same thing with biometrics. It really depends on what your research objective is, what your target population. Things along those lines are really important. And just like you had mentioned before, if maybe you do need a low N size, you do need a low sample size, you just have to, and that is as high as you can go. You just have to be prepared to accept that there is a chance that it is a low sample size, and there's a chance that it may not be a representative sample. Yeah. So there is that caveat.
Especially if you're planning on cutting the data further into segments, right?
Absolutely.
Because if you only have 100 people, and we know that statistically to get valid statistics, you need 75, that means you can't cut it into half and expect that 50 people are going to be representative. So if you have a question, for example, you have 100 people and you ask a segmentation question that might be, about, do you purchase this type of product, this brand? Are you loyal to this brand? And you have that as a segmentation. Well, it's then only 60 people out of the 100, and you're going to compare them to the 40. It's not large enough, right? You might need at least 100 of each group to be truly representative. So it kind of depends on the situation, but we do always remind the clients we work with of that sort of situation.
Great. So then what is the rule of thumb that we want to stick with? So it's really that idea to make sure that the sample size is large enough to compare to your target population. You're really trying to make sure that you're hitting those numbers that are important for whatever your research is, whether it's qual, whether it's quant, whether you're doing psychophysiological measures, maybe you're doing an IAT. It's, is the research online or is it in person? All of these things you want to keep in mind while you're going through it to really decide, am I hitting enough of a sample to call it representative? And like we have listed out here, you want to consider what you're trying to accomplish. And there's a couple of examples of the questions that you should maybe ask yourself while you're debating what N size is appropriate for your research.
Yeah, absolutely. So thinking about that normal distribution, thinking about the outliers, is it going to completely make everything where you can't trust the data? And that's the importance of all of this, is you're trying to trust your data, and you can only trust your data if it is truly representative of the people you're trying to measure. So with that, thank you for joining us for this discussion. We talked about things that certainly you could go into more depth in, so feel free to make comments in the comment section below, but also, of course, subscribe to this channel so that you can get updates on future episodes, so you can join us in the moment as soon as they get posted. And of course, reach out to us in all sorts of ways. You can link with us on LinkedIn, you can make comments here, we'll respond to them, you can email us directly, please tweet with us, tell us how you feel about this vidcast. We'd like to hear feedback. And of course, you can see all sorts of things that Kathryn and I have done on the blog, visit the website. But most importantly, thank you so much for joining us today.
Thank you, everyone, and enjoy your day. Until next time.
Please join us again. Bye.